So hello guys, welcome to my channel. I think you have followed the last video on this topic ITCT. So in the last class I have stopped there. I will continue from just a small recap. So I'll just have some look like we have how the information is measured and the types of informations on the units and all. So now coming to zero memory source, we do not see. So generally what happens, we just not toss a coin at once. Like basically we don't do that event just for once. We randomly throw dice or randomly throw coin, like toss coins. So for example, let us say tossing a coin, just take a consider that event. We toss the same coin several times, in fact m times. Suppose this source is memoryless, that is why output of the second toss does not belong to or does not depend on the first toss. So it is not a depending event. If we got it first toss as head and the second will be tail, we can't say that. So they are both completely independent. All those are completely independent events. Okay, outcome of the first toss and the subsequently any of the latter tosses are independent. This means there is no connection between any two symbols that the source has no memory, because basically it need not to remember the sequence, like if first it is this, so after it should be tail and then it should be head, like don't need to remember anything, just randomly whatever it gets it will give like that. So that it don't need to remember it. So that's why it is called zero memory source, or memoryless also you can call it. So now coming to how we can mathematically calculate all these. So let us take an example. Let us take a situation where there are q symbols that is represented as s1, s2, sq, so on, and with their corresponding probabilities as p1, p2, so on, pq. So what you are saying, L is the length of the symbol. Okay, let us consider long independent sequence of length L symbols. This long sequence then contains P1 into L number of messages of S1. What he is meant to say, P1 is the probability, right? When you multiply this probability with some number, like some quantity, like a unit like length, so in this entire length, how many are of this type? We can find out that. Okay, for example, if I want to know how many the type S1 are there in that entire sequence, just multiply the probability of S1, that is P1, with the entire length, that is L. Here now similarly P to L are the number of messages of type S2, and for SQ it is PQ into L. So for finding the self information of that symbol S1, we got log 1 by P1 bits. So similarly for others, it will be like PQL number of messages of type SQ containing PQL into log 1 by PQ. This is finding the number of messages of type S1 containing these bits of information. You got it, right? So basically we use generally we'll generally use only this one, that is self information. S1 is equals to log 1 by P1 and so on, SQ is equal to log 1 by PQ, like that. So coming to the total self information, we need to just add all those, that is P1 into L log 1 by P1 plus P2 into L log of 1 by P2 plus so on, plus PL, like so on. Last one is PQ into L log 1 by PQ. This will gives us a equation like L into, when you sum it up, like sigma I is equal to 1 to Q PA log 1 by PI bits. So this is like okay. Now coming to the find the average self information, just the average is like total by the length now. So total by this L will be sent to the left hand side, and we got this equation as average self information as the formula sigma is equal to 1 to Q PI log 1 by PI. So this is bits per message symbol. Units are more important, so practice it, what are the units and all. Next, average self information is also called entropy of S and denoted by H of S. So this value is called as entropy. So H of S is equal to sigma 1 is equal to 1 to Q PI log of 1 by PI bits per message symbol. So this is like some example. They are given as some symbols like a sequence s1 s3 s2 s1 s2 s3 s1 s3. This is some sequence of symbols where the probability of s1 by the total symbols is 3 by like basically probability. They didn't give the probability directly, so we need to find them. So how can you find total number of occurrence of the symbol by total number of symbols? So s1 has occurred 3 times, so 3 total are 8, so 3 by 8, like that. So similarly, to modify the above equation, we can find number of times the symbol occurred, that is 3 by 8 into total is 8. So we can find that there are 3, so we can see it is we are achieving the same thing. So p of si into l is equals to 3. Similarly, computing for others. Okay, so let us consider binary source alphabet s, s1 and s2 with probabilities they are given. So what is the entropy they are asking? So you know the formula, sigma I is equal to 1 to n, so 1 to q pq log 1 by pq. So pi log 1 by pi. So just do the form, like substitute in the formula and just calculate. We get this bits per message symbol. So average set, it is very small, and it is relatively very easy to guess whether s1 or s2 will occur. So what we will achieve by finding h of s? So we can know that whether s1 is getting or s2 is getting that the guess basically which has the higher probability to occur. That's it. So here we can say that s2 has a higher probability. So that means like basically what we can't say which one we get, but we can say that we can differentiate basically. So because this value is so small that, see, you can see the difference between the probabilities. This is 1 by 256 and it is 255 or 256. So that are too far away. Okay, their probabilities are too far away, so that we can distinguish. That one we can find here. Either we can distinguish or not. And it's the same thing. And if you observe here, this 7 by 16 and 9 by 16, we got 0.989. But here, if you observe, it is 0.03. So these two, the difference is too large, but here they are too near. So it will be hard to guess whether S3 or S4 will be transmitted. So next, let x represents the outcome of the sum rule. Okay. So we can do that entropy as px into log 1 by px. So 1 by 6 into log 1 by 1, that is 0.431. So here actually okay. So next, collector voltage of certain circuit is to lie between -5 and -12 volts. The total voltage can be, so the similar thing we need to have. They have given the like the values and the probabilities. Just use these probabilities to find the h of s, and you get bits per message symbols are the levels, because here given that is level, so we got the bits per level. So, and one more another thing is information rate. Information rate is the average source information, where let us suppose the symbols are emitted by the source at a fixed rate rs, that is symbols per second. The average source information, that is capital RS, will be equal to small rs into h of s, that is bits per second or bps. Okay, this is how you need to find information rate. And the h of s you need to calculate, and we know the h of s and rs in this question. They have given rs as 2000 symbols per second, that is small rs. Okay, if it is symbols per second, it is small rs, and bits per second is capital rs, like that. So if you confuse it with the statement, just you see the units and then next we can, this is okay, and the same modality, it was the same model. And this is the conversion, where how to convert heartlet to nats and bits. So here this information is equal to log of 1 by p base 10, that is heartless. So remember, I told you before, if it is just log of 8, that means it is base 2, not base 10. Okay, it is base 2. That's why you're writing bits here. Just remember that. So by default in this ITCT, if nothing is mentioned in the base, it is base 2. So if it is based in Hartley, you will get, and if it is base E, it is nats, and if it is base 2, it is bits. So this is an equation to convert one from other. I think okay. So nats and nuts and like that. So this is also one thing that we can see here. One nat is equals to 1.443 bits. Next, so this is 0 source, no need. Now coming to the fourth. So this is the problems, and these are some of the problems. So now properties of entropy. So coming to the entropy part, these are some few properties mentioned. So entropy function is continuous for every independent variable pk in the interval 0 to 1. Pk is a probability, so it will always be 0 to 1 only, and that if pk varies continuously from 0 to 1, so that's the entropy function. That means if you find the entropy for each of the value of it is particular value of pk, and we can see as pk varies from 0 to 1, that h of k also varies. Okay, now note entropy function vanishes at both pk is equal to 0 and pk is equal to 1. Okay, because at pk is equal to 0, it will be like 0 into 1 by 0, that is not defined, and also it will, we can consider that point, and pk is equal to 1 and it will be log 1, it will be 0, so that both the points will be vanished. The entropy function is the symmetrical function of its arguments. So if h of pk comma 1 minus pk is taken, and it will be same as h of 1 minus pk comma pk. This will be understood more in further classes, so just remember for now, that is the values of h of s remains the same irrespective to the location of the probabilities. As long as the probabilities are same, it does not matter in which order they are arranged. That's the sources SA, SB, SC with probabilities. If like suppose if the source symbols and the probabilities 3 ABC, then it will be 1 by 3, 1 by 3, 1 by 3. Then the order does not matter anyway. So properties of entropy, coming to this, and external extremal property. Let us consider the same sources with q symbols s. So we are taking the symbols with the probabilities. The entropy s is given by an example, like you are using this formula, and we know that sum of all the probabilities of particular event will be 1. Okay, so hence we can see that it will be h of s max is equals to log q base 2 bits per message symbols. So remember this formula, because it will be useful for at the end of these sessions to find the capacity of the channel and all. We'll take this, so remember this one. And the entropy attain a maximum value when all the source symbols become equiprobable. So what they are saying, that when the probabilities of all the events are same, so symbols are same, will attain the maximum value of entropy. So property of additivity. So suppose I split the symbols sq into n sub symbols, that is sq of is equal to sq1 and sq2 so on, occurring with the probability pq1, pq2 so on pqn. So pq is equals to sum of this one, all the probabilities. So we can do that one also, property of additivity. Now for the source efficiency can be calculated by h of s by h of s max. So this is how we find the h of source efficiency, and also for channel efficiency also this is the same formula. Same goes for source redundancy. Redundancy is the 1 minus efficiency. So if you want to get it in percentage into 100, you need to do. Okay, if you don't do 100, it will be some normal value between 0 to 1, and the same for this one also. So they have given some symbols and the probabilities. H of s we found that, and for max there are 4 symbols, right? That's why it is log q base 2. Okay, 4 source symbols, that's log 2 base 2. That's how we got to the h of s max. And when occur, for example, if this 4 symbols has equal probability 1 by 4, what he is explaining is this maximum occurs only when this all the 4 has the 1 by 4 like equiprobable. Okay, coming to the next one. So this problems same. Okay. So okay, this is also problem one. This is also a problem. Okay, extension of zero memory source. This is what is meant by extension of zero memory source. This is what in if the events doesn't have any dependencies, the symbols doesn't have any dependencies, we told that it is zero memory source. Now coming to the extension of this, if you take two bits, for example s1 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 s2 s2 s1 s2 s2, these are some of the few combinations for two symbols, right? So if you take two bits as a one certain symbol, then pair or you can take 3 4 like that, anything will, this is like second extension, third extension, so on will come. So basically the extension of zero, so this is what he says. And for example, let us take two symbols with the probabilities p1 and p2, and their sum will be 1. Then the second extension of this symbol, so second extension means two symbols, pair of symbols, third extension was 3 3 like that. So here we got that s1 s2, and we know that both the events are independent, so we can multiply the probabilities p1 into p2, that is p1 square, and s1 s2 p1 p2, s2 s1 p1 p2, s2 s2 p2 square, and all this sum up will result in 1. So when you look at the formula, it is like a plus b whole square, so a plus b whole square is equal to 1. We got that again p1 plus p2 is equal to 1, the same thing. So for finding the entropy for this, so h of s with the same, we know the symbols and the probability that and h of s won't be changed for not like normal. When it comes to second extension, to find the second extension, it is the h of s whole square. So when it comes to h of s whole square, this now these pairs will become the individual symbols. This s1 s1 is some new symbol, s1 s2 new symbol, s2 s1 is a new symbol, and s2 s2 is a new symbol with the corresponding new probabilities. So we have 4 symbols. So now we use the same formula, that is p1 square into log of 1 by p1 square. For s1 s2 it is p1 p2 into log of 1 by p1 p2 like that. You understand it? Just see them as a new set of symbols, that's it. Okay, for in general the nth extension, so when we substitute and solve everything, what we got was some 2 into h of s only. That from this understanding, what they have come to a conclusion that for an nth extension of this binary source, we'll have 2 power n symbols. Yes, it is true. And then entropy of that nth extension is given as n into h of s. That means if they have given only normally single s1 s2, and they asked for the entropy of fifth extension, what we'll do, 5 into h of s of the normal one, that's it. So the same thing, no new thing is there, and it is that second extension, I think it is 3 symbols, so symbols having 3 power 3 square, okay, 3 symbols, right? And we need the second extension, I think. Okay, to write this generalized formula, I think it is not the right way. Rather than this, we can say that it is only 2 symbols. So what we got, for 2 symbols it is 2 power n symbols, right? You got it. For 3 symbols and we want the second extension, it will be 3 power n. That's what, like that. So here they are asked for 3 symbols. There are 3 symbols again, and the second extension, we need the second extension to 3 square, that is 9 symbols will get 9 combinations, and each symbol now becomes a new symbol, and the corresponding probability is a new probability, and do the entropy and so on. And still we got and this formula won't change, that is n into h of s is proved. The same thing. Thank you. 7th one. So coming to this, the code produced by the discrete memoryless source. Okay, source coding. Now coming to source coding, I think I will teach this in the next session, and thank you for watching. And I think it's only 20 minutes of the lecture, it's fine. I will start this topic source coding in the next session, or let me check 1 minute. So what are the things that are present in source code and properties of codes? And okay, I will teach this entire source coding in the next lecture. Thank you for watching. If you don't haven't subscribed yet, please do subscribe, like, share. And to watch the video previously, you can go to the playlist and you can search for ITCT and you will get it. Or I will also keep this in the at the end of the video. So thank you for watching. Do like, share and subscribe.